Let me tell you about a shocking discovery that is currently sending ripples through both the astronomical community and national security circles. On November 2nd, the night sky recorded an event with almost no precedent. A talented amateur astronomer, Gennady Boris, while making routine observations, accidentally spotted a highly peculiar object, a chunk of ice or rock grazing incredibly close to the Sunday. It was so near that its orbit appeared to be almost absolutely bound by the gravitational pull of our star, leading many experts to immediately raise the question, is this an interstellar visitor that has just strayed into our cosmic backyard? However, it is more likely that this object originated from the furthest reaches of our solar system, perhaps from the enigmatic Oort cloud. But what has truly caused all of us to have chills is the terrifying coincidence surrounding this event. In the very same week, another genuine interstellar visitor, an object that we are 100% certain originated from outside the solar system, was also passing close to the Sunday. That object is 3I divided by Atlas. The undeniable evidence lies in its unmatched speed. Atlas is hurtling through space at up to 60 kilometers per second, making it over 600 times faster than the quickest race car ever to hit Earth's NASCAR track. There is one fundamental difference we must keep in mind. Atlas is completely untrapped by the Sunday. It is a free-roaming nomad, rushing into and soon to rush permanently out of the solar system. Conversely, the object Boris observed appears to be almost gravitationally held by the Sun, having perhaps only recently entered this extreme perihelion orbit from the outer fringes of the solar system. This leaves us with only an incredibly brief window to detect and study it. Yet, it is this simultaneous appearance that sparks the most haunting question. Could these two strange objects truly be related in any way? Could C divided by 2025 V1 be the cosmic scar that Atlas inadvertently left behind after its 10 billion year journey across space? If Atlas is just a natural comet, a dirty snowball, then during its travel at that impossible speed, it could certainly have broken up, leaving a fragment of ice and rock to be gravitationally captured and dragged into the solar neighborhood. That is a plausible, natural possibility. But what if we entertain the bolder hypothesis, the one that Avi Loeb and his colleagues at the Galileo project are pursuing? If Atlas is a technological mothership belonging to an ancient civilization, could it have deliberately dropped a probe into our inner solar system? A probe designed to maneuver itself, conduct research, and then appear almost deceptively captured by the Sun's gravity? This is the question that makes our head spin like a small planet orbiting its own light, because the universe always knows how to throw us the most challenging mysteries. Yet, as often happens in the detective story of science, the immediate facts attempt to dismiss the dramatic conclusion. When orbital calculations were performed, the results seemed to deliver a cold splash of reality, suggesting the relationship we are hoping for simply does not exist. The new object, C divided by 2025 V1, possesses an orbit that is calculated to be almost perfectly perpendicular to that of Atlas. Furthermore, the closest they ever came to each other was estimated to be around 100 million kilometers. This distance, in astronomical terms, is simply too vast for any natural recent connection to be plausible. Their simultaneous appearance near the Sun appears, on the face of it, to be nothing more than a profound and highly unusual cosmic coincidence. However, if we refuse to discard the technological hypothesis, if we place the possibility of an engineered device on the scale, then the equation changes completely. We cannot, under these circumstances, rule out the possibility that an object is capable of performing a maneuver. An advanced device could potentially alter its trajectory and change its orbital plane, moving between two seemingly unrelated paths with the goal of observation or deployment. It is hard not to feel a sense of, wow, because sometimes it is the most unlikely coincidences that raise the biggest and most challenging questions about our universe and our place within it. This leads us to delve deeper into the nature of 3I divided by Atlas itself. If it is purely a natural object, then its unprecedented velocity offers a startling clue about its true age and parent star. Objects ejected at such high speeds often originate from much older star systems. Older stars typically experience gravitational interactions over longer periods of cosmic time, meaning the objects kicked away from them can achieve speeds far greater than those found in younger star systems like our own. The raw calculations derived from its velocity suggest that Atlas could be as much as 10 billion years old, a truly mind-boggling age that would make it roughly 7 billion years older than our Sun itself. An object carrying the history of a star that long dead is a profound thought. But again, this astonishing conclusion holds true only if Atlas is a completely natural, unpowered object. We have no way of knowing the initial speed at which its parent star launched it, so its actual travel time remains an estimate, a hypothesis built on current models. And crucially, if the technological hypothesis is raised, if we consider it to be a manufactured device capable of interstellar travel, then all of our natural calculations about age and journey time become instantly meaningless. The question then shifts from how old is it to who sent it. They could be surprisingly close and the journey was short, or they could be unimaginably distant, having launched this device long before the first humans even walked the earth. This level of speculation is what keeps scientists and the public glued to the skies. Continuing this profound conversation, an important and very humbling question arises. Why are we suddenly seeing more of these interstellar visitors, especially given the sheer, overwhelming, mind-boggling size of the entire solar system? If we are talking about randomly drifting objects, such as chunks of ice or interstellar rocks, then the number of these objects we have recently managed to detect in the inner solar system, the relatively small region between the Earth and the Sun, implies a colossal presence. It suggests there must be approximately 1 trillion such objects floating throughout the entirety of our solar system today. This number, roughly $10 circumflex, $15, extends all the way to the very edge of the Oort cloud, which is about 100,000 times the distance from the Earth to the Sunday. The reason we encounter them so rarely, however, is simply because the volume of space at that immense distance is so astronomically vast. When the radius of a sphere is extended 100,000 times, the overall volume of space increases exponentially, becoming enormously larger than the relatively confined region around Earth's orbit. Therefore, for every one of those rare objects that manages to wander into the vicinity of the Sun for us to observe, there are literally trillions of others that float silently in the absolute darkness of distant space. And if those objects were formed randomly, then every single star in our galaxy must have created an equal number, meaning the universe contains an unimaginable silent sea of matter, of which we have only glimpsed the very tip of the cosmic iceberg. Another powerful question that has been raised by the public is a deeply emotional and philosophical one. Would the definitive discovery of Atlas as a spacecraft bring humanity joy or profound worry? If such a truth were revealed, the first prevailing emotion, argues Avi Loeb, would be one of immense joy. This is because humanity seems to be in dire need of a true jolt of cosmic humility. We have a regrettable tendency to place ourselves instinctively at the very top of the food chain, not only here on Earth, but sometimes implicitly assuming that status in the entire universe. We consume other animals because we deem them less intelligent, and we certainly would never touch a creature we considered intellectually superior. This mode of thinking breeds a deep complacency, making us easily forget that our current knowledge is only a tiny, fleeting part of a much, much larger picture. Artificial intelligence may already be starting to teach us a measure of humility, but if there truly are brothers and sisters out there, civilizations far more advanced than our own, it will be the single most profound lesson in humility humanity has ever been forced to receive. And above all, their undeniable presence will instantly open up invaluable, unprecedented opportunities for learning and growth, much like when we suddenly discover that the smartest person in the class understands concepts far beyond our wildest imagination. This is the ultimate prize in the pursuit of the unknown. As the story continues to unfold, I truly feel as if I am back in the classroom, where one profound question immediately follows another, opening up countless intriguing hypothetical scenarios. One of the most immediate and urgent questions comes from a viewer named Hug. What would happen if an object of Atlas's size and velocity actually collided with Earth? The answer, unfortunately, is extremely grim and must be taken seriously. Such a collision would be just as devastating, if not more so, than the catastrophic impact that is credited with wiping out the dinosaurs. Recall that cataclysmic event. An asteroid roughly the size of Manhattan Island slammed into our planet, initiating a chain reaction that caused the entire global ecosystem to collapse. The dinosaurs simply could not survive that moment. And the prospect of Atlas colliding with Earth would carry similar, if not even more devastating consequences for all life. Fortunately, for now, there is absolutely no sign that Atlas is approaching Earth in any kind of threatening trajectory. In fact, current reliable forecasts suggest it will come within a comfortably safe distance of about 250 million kilometers around December 19th. That wide margin is more than enough to fully dispel any immediate existential fears of a collision. Yet it is close enough for astronomers to deploy their most powerful telescopes and observe it in detail. This critical window will allow us to collect substantial new data, unlocking many of the fundamental mysteries surrounding the true nature of this object that has scientists and the general public watching with a unique mixture of deep curiosity and overwhelming wonder. In recent days, however, new observations have revealed something truly surprising and highly controversial. More than 7 powerful jets ejecting material from the object's surface. One completely natural possibility is that these jets originate from pockets of ice beneath the surface where sunlight heats the ice and causes it to sublime, sending plumes of material shooting out into space, sometimes traveling millions of miles. This is a common phenomenon seen with comets. But, as always, there is also a much more daring possibility, the hypothesis that has scientists talking in hushed tones that these powerful jets are, in fact, some kind of propulsion technology, the exhaust system of an advanced spacecraft. The truly exciting and decisive thing is that we can distinguish between these two scenarios quite clearly using physics. An artificial propulsion system would generate exhaust velocities vastly higher than the slow, natural jets produced merely by sublimating ice. This means that by precisely measuring the velocity of these 7 jets over the next critical few weeks, we should have a definitive, unmistakable answer as to the true nature of this intriguing interstellar object. This is a scientific pursuit that resembles a high-stakes detective story. It is precisely at moments like these that the scientific endeavor becomes truly fascinating, when the search for universal truth begins to resemble a high-stakes detective story with vital clues scattered across the deep expanse of space that need to be deciphered bit by meticulous bit. In this specific case, observing Atlas is akin to following an astronomical cold case, with each new piece of data revealing a new and deeper layer of mystery. It genuinely feels like we are witnessing a cosmic version of a Sherlock Holmes investigation, except that the detectives this time are not men in tweed coats, but rather dedicated scientists and the world's most powerful telescopes pointed heavenward. This brings us to another critical and highly controversial question that arises from the community. Why do so few scientists, sometimes seemingly only Avi Loeb and his immediate circle, dare to seriously consider the possibility that this object might be something beyond the familiar, comfortable stereotype of a natural comet? This deep reluctance largely stems from long-standing, ingrained habits within the broader scientific community. Most researchers traditionally deal with objects that are billions of light years away, like galaxies at the very edge of the observable universe. These distant objects, no matter how profoundly mysterious their properties, simply do not possess any direct or immediate consequences for human life, culture, or survival. Consequently, most researchers tend to stick safely to the most likely and conventional explanation, even if that explanation is demonstrably incomplete. But when we are faced with an interstellar visitor right here in our own backyard, the situation immediately becomes fundamentally different and infinitely more urgent. If the object is even remotely technological in nature, it could pose an existential risk to humanity. Governments and intelligence agencies operate under a completely different imperative. They inherently understand that low probability, high consequence events must always be taken with the utmost seriousness. I believe, therefore, that the entire investigation of this object must be conducted in this crucial spirit of risk management. We must collect absolutely as much data as possible, carefully identify its true nature, and ensure, beyond a shadow of a doubt, that it is nothing more than a harmless, drifting rock. Most scientists, however, view this complex situation as a simple classification problem, where the most probable explanation is automatically assumed to be the correct one. This brings us to a pervasive problem in the professional community. Take comet experts, for instance. They have been trained their entire professional lives exclusively to study comets. Their massive data set consists almost entirely of comets. This makes them operate much like an artificial intelligence system trained on only a single narrow set of data comets. And just like any AI system, if the input is always one type of object, the output will almost always be one type of classification. Anything they see in the sky, through that rigid way of thinking, automatically becomes classified as a comet. I have continually attempted to explain to my peers that their inherent data set desperately needs to be expanded, starting from the simple, undeniable fact that humans themselves have successfully sent spacecraft out into the void. This proves without question that there is far more to space than merely rock and ice. There is also the very real possibility of technological objects. When an object that is proven to be from outside the solar system enters our celestial neighborhood, it only makes logical and intellectual sense to fundamentally expand the scope of our consideration rather than confining it solely to the most familiar, restrictive, scientific framework. However, many in the community have not accepted this premise, and some have even publicly criticized me for not being absolutely convinced that the object must be classified as a comet immediately and without further investigation. But science, if it is to achieve genuine progress and move forward, must maintain a willingness to accept possibilities that we have not previously considered or included in our models. Speaking of scientific progress, Avi Loeb brings up a deeply frustrating question regarding bureaucracy. Does the recent closure and restriction of some NASA laboratories significantly slow down the pace of investigation into objects like Atlas? He recounts a truly critical incident when 3I divided by Atlas reached a distance of about 29 million kilometers from Mars. The high-resolution camera mounted on the Mars Reconnaissance Orbiter MRO, captured what should have been incredibly valuable, sharp data. These images were considered the crispest, most detailed we could possibly obtain at the time, offering a resolution of about 30 kilometers per pixel. But here is the infuriating crux of the matter. These images were taken on October 3rd, precisely 2 days after the partial government shutdown began. NASA, due to rigid and paralyzing administrative constraints, issued a statement saying it could not release this vital data to the wider scientific community or to the public. To this very day, more than 40 days have passed since those incredible images were captured, and the data has still not been shared. Loeb argues that this incident is a clear and damning testament to how bureaucracy actively trumps science in modern government operations. He insists, quite rightly, that scientific data must be utilized for the advancement of science and should never be held hostage by administrative red tape. At the very least, he states, the data should have been shared internally with core researchers so they could effectively design future observational campaigns with ground-based telescopes. That simply hasn't happened. Loeb believes that NASA's higher management needs to step in decisively and put an immediate end to this nonsense until the government reopens fully. Meanwhile, he and the entire world can only wait impatiently to finally see the images captured from Mars orbit. It is against this backdrop of bureaucratic paralysis that Loeb tells us about the crucial work being done by the Galileo project, which he launched several years ago. He initiated the project immediately after the U.S. government and various intelligence agencies officially reported to Congress that there were unidentified objects appearing in the sky objects, now commonly known as UAPs. In the most straightforward terms, these mysterious objects could represent advanced devices built by hostile foreign countries, posing a direct and undeniable national security risk. This, Loeb stresses, is extremely serious, especially considering the U.S. government spends trillions of dollars annually on defense, and yet still cannot identify some of the objects that appear in its own sovereign airspace. However, he also compellingly notes that the breathtaking possibility of these objects being extraterrestrial in origin cannot be logically ruled out. As an astronomer, Loeb is, by definition, deeply and fundamentally interested in everything that lies beyond the solar system. If any of these objects are indeed extraterrestrial in origin, their confirmation would instantly become one of the greatest and most profound scientific discoveries of all time. This dual possibility, national security threat versus ultimate scientific discovery, is what drove him to create the Galileo project. His dedicated team now operates 3 state-of-the-art observatories, tracking millions of objects every year and using sophisticated machine learning algorithms to search specifically for a highly unusual flight behavior that could be telltale signs of artificial technology. The project has also launched an ambitious and unprecedented expedition into the Pacific Ocean with the goal of collecting material from an interstellar asteroid that previously collided with Earth. The U.S. Space Command has definitively confirmed that this particular asteroid originated from outside the solar system. Therefore, Loeb is determined to test whether it might be some kind of exotic technological voyager. The recovered sample material is still undergoing intensive analysis. Additionally, his team continues to study other significant interstellar objects, such as Oumuamua, the first such object to appear in 2017 with its many strange properties, and now 3 I divided by Atlas, which is deservedly attracting tremendous global attention as his team continues to collect crucial new data. For Loeb and the Galileo project, each fresh piece of data is another critical piece in the sprawling, enigmatic puzzle of expanding human understanding of what truly exists beyond the familiar, comfortable edges of our universe. Loeb concludes his conversation by noting that the time for the discussion is nearly running out, but he is deeply grateful for the opportunity to answer countless insightful questions from the audience. He remarks that as soon as one question is answered, a series of new, equally compelling ones immediately surface, powerfully demonstrating the public's robust and enduring curiosity about 3I divided by Atlas. According to his team's latest analysis, this fascinating object will be closest to Earth right around Christmas time, maybe just a week or so earlier. Given the sensitive timing of Atlas's approach, the public fascination is intense. Loeb was reminded of an interesting, slightly humorous anecdote from a previous conversation when the government was shut down and NASA was under severe restrictions. It was reported that Kim Kardashian was contacted before him to discuss the situation. When asked if the reality star had responded to his scientific questions, Loeb smiled and confirmed he was still waiting. He insisted he would be happy to give her all the information he knows, as well as explain how the process of science operates like a truly fascinating, high-stakes detective story. He said that tracing the nature of an interstellar object is just as thrilling as following a lead in a complex case, and he believed Kim Kardashian would enjoy that approach if she were genuinely interested and wanted to learn. Loeb went on to express a profound conviction that he does not view himself as belonging to some privileged academic class. In his mind, he is simply a regular member of the public, just like those who are following this conversation and are curious about this enigmatic interstellar object. He firmly believes that we all possess the innate ability to figure out the truth for ourselves, relying solely on the clues we gather from careful observation and rigorous analysis. This does not require waiting for pronouncements from rigid officials or slow-moving regulators. It is a process akin to children solving a puzzle, driven by pure curiosity and an eagerness to explore the unknown. At the end of his talk, Loeb stated that the greatest gift science has ever given him is the invaluable opportunity to retain his childhood curiosity. For him, being allowed to look at the world with open, questioning eyes, constantly asking deep questions, and actually being paid to do so is truly the greatest privilege of his life. Science, he feels, is a continuous journey to nurture imagination, curiosity, and a relentless passion for finding answers in a vast universe that humanity has only just begun to comprehend even a very small part of. As 3I divided by Atlas approaches Earth right around Christmas, the event is drawing intense attention, not only from astronomers, but also from the national security community and those closely watching the global space race. What makes the entire story even more tense is the highly sensitive political timing of its arrival. The U.S. government is partially shut down, NASA is restricted from releasing crucial data, and major world nations are still quietly jockeying for any technological edge in orbit. Against this backdrop, Atlas's appearance, still unclearly classified, has instantly become the focal point of intense speculation. Many experts suggest the level of bureaucracy that has delayed the data may only be the tip of the iceberg. Some openly question whether the secrecy surrounding the Mars Reconnaissance Orbiter's images and information reflects something far larger, a shadowy battle of wits between superpowers seeking to control any clues about extrasolar objects. Ultimately, Atlas may turn out to be just a random visitor from afar, but its arrival is timed sensitively enough to spark every level of speculation, ranging from pure science to geopolitics, from factual analysis to the elaborate conspiracy theories that have become an integral part of modern global culture. The only thing that remains absolutely certain now is that as Atlas closes in on us near Christmas, all eyes will be fixed on the sky, not just to discover what it is, but also to see if its truth fundamentally changes the way we see the universe and ourselves forever.